Welcome to this video, and in this class we are gonna solve these questions here, and these are questions that are using by parts. And so what we have to remember, what we're going to use here is the integral of u dv is just going to be equal to uv minus the integral of v du. So what is key to solving these questions? So the key is you have to identify your u and you have to identify your dv. Then what you do is you differentiate your u and you integrate your dv, and then you replace your u, your v, and of course you replace your v du in this part here. So how do we do that? Let's go straight into the first question, and we have that the integral of x squared sine x dx is what we're trying to find. So now here, let's identify first the u. So here, what we'll use to identify, we'll be saying this word Liate, L-I-A-T-E, where the first one stands for logarithmic function. This one stands for inverse trig function, algebraic function, trigonometric function, and exponential function. So this is how we are going to be setting our u. So when I look into my function here, I see which one comes first. So algebraic, which is the x squared, comes before my trigonometric function. So here what I do is I let my u to be equal to what? I let my u to be equal to x squared. So u is going to be equal to x squared. So that's my u. Then I say my dv. Whatever remains, whatever part remains, this part that has remained, that will be your dv. So dv is going to be equal to sine x dx. Then what you do here with your u, you differentiate. So when I differentiate my u, I just get this will be du equal to, then this part here, I just get it to be 2x dx. Then when I integrate the other side now, so the other side you integrate. Even this side here, you integrate. So when you integrate here, you get that v is just going to be equal to, integrate here, then you get negative. So this will be negative cos x, like that. So this is what you get. That's your u. So you have your u, you have your v, and of course you have your du there. So now you can replace in your what? In your formula, which is here, where it's saying uv minus the integral of v du. So when I replace now, what am I going to have? So saying the integral of x squared sine x dx is going to be equal to, so what is my u? So my u here is just x squared. So my u is x squared. Then what is my v? My v is negative cos x. So this will be multiplied by negative cos x, like this. So that's what I get there. Then minus the integral. Then my v, what's my v? My v is just negative cos x. Then of course my du is 2x dx. So here I'll put my 2x dx. So now from here, how is it going to be? So now from here, let me erase this part. So to erase this part, okay, so erasing this part, I'm going to have, so now I can move here, this negative multiplies with that negative, then I can move the 2 in what? In front there. So I write the first part the way it is, that is 2x cos x, like that. Then that becomes positive, so plus 2. Then I say the integral of, so I have x, then I have cos what? Cos x, then dx. I see now that from here, again, I would have to employ what? I would have to employ that by parts here again, because I have an x and I have a what? I have a trigonometric function here. So I have to do again by parts for the second time here. So what do? I let my u to be equal to what? To be equal to x. Then I let my dv to be equal to whatever that which has remained, which is just going to be cos x dx. Then I differentiate here, I just get du is equal to what? To dx. Then this will be equal to v. When I integrate here, this will be v. Then what does this other part give me? So from there, this gives me here sine x. So this gives me sine x. So that's what I get there when I integrate. So now I replace again this part here. This part here, I'll replace that there. So I'm just going to have that. So when let me erase this part. So we're just going to have that this here. So here is going to be, we have since, okay, so we say this will be equal to, so the first part you already have your x cos x like this plus 2. Then now what we're replacing is this part here, the part where we are actually what? The part where we are actually integrating. So now from here, how am I going to do it? So I have to just make sure that I replace here my u. So my u is what? My u is x. So my u is x and my v is sine x. So if my u is x and my v sine x, I just replace there, then I just get that this will be x sine x. That's on the first part. Then we're saying minus what? Again, I have to say v du. So my v is here. So the integral of v, that's sine x, then du is just dx. So here, the sine x, then there I'll have what? Dx like that. Then of course, that's what I get. Okay, so I can erase this part here. Then I'll just have that from here. This will follow that I'll have negative x squared. Then this will be cos x plus what? Plus 2. So cos x plus 2. Then I'm multiplying now. I'm multiplying what? So before I multiply here, x, so I have x sine x. Here I can what? I can integrate. So integrating, I end up with negative there. Then I have integrate sine x, you just get negative cos x. So negative cos x is what I have there. So this will be equal to negative x squared. This will be cos what? Cos x. So here I can now multiply the 2. So the 2 becomes here be 2x sine x. This becomes positive. Then this becomes plus 2 cos what? Cos x. Then of course we are saying now, yeah, you're adding a what? You're adding a constant. So you'll be adding a constant, which is c. So this will be here a plus what? Plus c, that is your constant. So plus c, which is your constant. So if you want here, you could now just finish up to say this will be negative x squared cos x. Then, of course, this would just mean that it's bringing us to the top part again, if I am just to factor out. But I think here, just ending it here would be okay. Let me write the answer in yellow that you're able to see it more clearly. That's 2x sine x, then plus 2 cosine x. Then, of course, we're saying plus c, and like that, you have integrated using what? Using by parts. Okay, now let us do the same for the questions that are going to follow here. So let's now move on to part B. Okay, so part B, what does it say? It has the integral of cos inverse of what? Of x, then dx like that. Cos inverse of x, then we're saying dx. So as we said here, the Liate, L-I-L-T-E, this helps you to identify which one to set to be your u. So logarithmic, you check, do you have a logarithmic function there? No, I do not have. Then I, inverse trig. Oh, we have inverse trig already. So that's going to be cos inverse. It's going to be my u. So I say I let my u. So here, let your u just be equal to what? To that cosine, cos inverse of what? Of x. Then your dv, of course, whatever remains there, whatever remains is going to be what? Is going to be your dv. And you see that what has just remained is what? Is dx. So here you differentiate the du. You just get, differentiate, you get the du. Then that part there just gives you, differentiate this, you get 1 over root 1 minus x squared. Then we're saying d what? Dx, since you're doing it with respect to what? To x. Then From here, you integrate here your dv. So integrate this here, it gives you v. Integrate the dx, just get x like that. So I have everything I need. I have my v, I have my u, and of course I have my what? My dv also. But then what is important here, according to that formula, is just telling us you need your u, you need your v, and of course you just need your what? You need your dv. So now I can replace this here. So when I replace, I'm just going to have my u is what is cos inverse there. Then my v is what is x. So I have x cos inverse of what? Cos inverse of x. So this is what I get here. Then from here, minus, of course, then the integral, my v is what is x. Then du is all this what? This thing here. So I just end up having x, then my what? My du is this whole thing here, which is negative root here of 1 minus x squared like that. Then, of course, dx there. So this is what I get. Now, after getting this, how am I going to handle this one here? How am I going to handle this one here? So you see here, you can, this is a negative, you can multiply that and multiply the x there. So this negative and that negative become a positive. So you have cos x, um, x cos inverse of x. Then here you just get this will be a plus. Then there you get x. Then you have what? Root of 1 minus x squared. So then of course dx. So now at this stage now, this becomes so easy to do. So because it's become so easy, we can simplify this well. So what do I do next from here? So I see, okay, how am I going to what? To integrate now? I have to just integrate this part. So how do I integrate this part? Okay, so this part I can just use what? I use substitution. So I say let u be equal to what? So I'll let my u be equal to what is there in the root, which is 1 minus x squared. Then I get this will be du, then this will be 0. Differentiate a constant, you get 0. Differentiate that negative x squared, just get negative 2x. And of course here I say dx, 2x, then I say what? And then I say dx. So what next then do I do here? So here, I see that here there's an x and there's a dx. So let me leave that there. So where I say I divide by this negative 2. So when I divide by the negative 2, I just get negative uh, du over what? Over 2. Then this is equal to just x to what? Dx. So it means where I see an x dx, I'm replacing this negative du over what? Over 2 is what I'm going to use. So where is my integral? It's just this part here. So this part here says that when I integrate here, I'm just going to integrate and say that so here I integrate my x. So I mean this integral here. Then I replace here what I have to replace. So what do I get? So this will be the integral of, on top there I have the negative du over what? Over 2. Then down there divided now by what? Divided by the root of u here, like this. So this is what I get. But then I can move the negative half in front. So I get negative 1 over 2, like that. Then here I get this would be 1 over root u du, like that. After getting this now, of course I can write this in the form, this will be negative 2 root, then I can write this as u negative what? Negative 2, like that, to the power negative 2, then I say du. Then I can now what? Integrate this. So when I integrate, I don't want to rub this last part there because we just can replace. So let me erase this part here. Then we say that will be negative 2 here. Then we're saying integrating the u to the worst, that will be just me adding now u negative 2 plus 1 in the what, in the exponent there on the power, the negative 2 plus 1 in the what, in the denominator, then you're just going to have this will be what, a plus c like that. Then what does this lead me out to? So you see the negative by this negative is just going to what, to cancel out. And then also because I have half, so here when I add, so negative 2 plus this what, I mean negative 1 over 2 plus the 1, that just gives me half. So I'll get that this will just be half like this. Then I have u. Same in the bracket, in the denominator, I mean in the exponent, I get 1 over 2. Then down there also I get what? I'll get a half. But then I can write that just as what, as 2 there, because it is dividing. That half is dividing there. So I just write a 2 there. Then I can divide this there into there. Then I remain with a negative there. And of course my constant c. So I'm going to have this will be negative u half plus 1 plus c. Then after getting this here, I know what my u is. So this implies this will be negative here. My u was just 1 minus what? Minus x squared, which is this one here where I can see, and plus what? Plus c. So now it means where there's this part here, I'm just going to replace what I have found, which is this here. So, okay. So I write it like that. So now this here means I'm going to have, if I erase this part here, erase this part, and I finish up that answer. So it means this is going to be equal to x cos inverse of x. Then you have what? Minus root of 1 minus x squared, then plus what? Plus c. So this here is what I get when I integrate. Okay, so next we go to the next question. The next question now has the introduction of an exponent, but then it doesn't really matter because the exponent in the word liate is the one which is at the end. So it's the integral of x here, then I have sine x dx like this. So after getting this one, what do I do? So after getting this again, I have to say, okay, I want to let my u first. So when I look at this word here, I see it's logarithmic, it's inverse, trig, it's algebraic, then I get the next one is trigonometric, then of course exponential at the end. So now I see that the trigonometry comes before the exponential. So meaning I am gonna let my u to be equal to what? The trigonometric function, which is just sine x in this case, sine x. Then the rest there, which is dv, is just going to be equal to what? To e to the x, then d what? dx. So here, the usual game, I differentiate, I get du here, then differentiate this sine, this gives me cos x, then here I integrate the dv, gives me v, then I integrate the versus the e to the x, and I just get e to the what? E to the x like that. Then I can replace this now. Since I have my u, have my v and my dv, then I'm just going to have this will be equal to uv, my u and v, I just have this here, e to the x sine what? Sine x. Okay, then minus, then I have my v again, which is e to the x, then my du is just what? Cos x. Here we forgot the dx here. That will be cos x again, d what? dx. Oh, we still end up with such a function here like this. How do we do it again? It means we have to what? We have to do integration again here for us to be able to what? To solve this question. So let's go again. So what do we do now? Okay, so we say so it's this part again, we have to do there by parts because of the e to the x and the cos there. So again, I let my u to be cos x, then I say dv, here, then so dv is just what has remained, which is the e to the x dx, then I have my, so I should differentiate here. So when I differentiate, I get du is equal to what? To negative. So that will be negative sine x dx. Then I integrate this here, I get v. That will be what? E to the x. Yeah, just that will be e to the what? To the x. So now from here I can replace the same. So what do I get? So meaning that integral e to the x cos x dx is going to be equal to, so this now e to the x, e to the x is just going to be, so from there, okay, from there I have my v, I have my u, so that will be e to the x cos x, like that. Then I have minus, then what am I going to have? Here there will be v, so you say v, which is e to the x, so e to the x, then what? Um, e to the x, which is our v, then our du is negative. So the negative actually can multiply this negative, this becomes positive. Then I get that I have sine x to what? Dx. I have sine x dx as what has remained there. So now from here, how do I work it out? How do I work this out? So, okay. So I see here yet again that I'm going to end up with what? With this part here. This part, which is the first thing again that I am integrating again. So what am I going to do here? So again, I'll just replace which I found. So this is going to be, so I replace in this here, and I'll have that this is going to be e to the x, like this, sine x, then sine x, then what? So that will be negative. If I put this whole thing here, negative, that would be negative e to the x. So negative e to the x cos x. Then of course, again, I'll just say minus. So this will be minus the integral of e to the x sine x dx. But now, keep in mind that at this stage of the question, what we just have is, that this side here, this is the integral of what? We're finding the integral of e to the x sine x dx. But we see that this is the same with this. So we can able to what? We are able to group that there. So I take it all to the right side, and you see that this is just addition. So when I add the two, what I get is, of course, 2 in front of them. So I get 2 integral of what? E to the x sine x dx. So this is what I get. Then on this side here, what do I get? So this side I get that I have e to the x, then I'll have what? Sine x minus cos x, like this. Then now I divide the 2 throughout. So I divide the 2 throughout, meaning on both sides. I divide that 2. I'm just going to have that this is going to be the integral of e to the x sine x dx. So then there I just get e to the x divided by what? Divided by 2. Then I have sine x cos, then I have sine x cos what? Cos x, like this. Then I add my constant what? Constant c. And that's how you integrate that. Okay, if you are new to this channel, remember to subscribe and hit the like button, and share this video. Well, this is where we end, and this is how you just apply that by parts, and this is how it works. We'll see you in the next one.